In this video, we're going to go over how to do simple logistic regression. Here's the assumptions that underlie what we're doing. We have one independent or predictor variable, and we have one dependent or outcome variable. And this outcome variable only has two possible values, so it's dichotomous or binary. Yes or no, employed or unemployed, pressure sore or no pressure sore, lung cancer or no lung cancer, whatever it is, it only has two possible values. And we're also assuming all of our data points are independent. So when you collect your data, you're not going to calculate logistic regression by hand. You're going to put it into a program like SPSS or some sort of web interface and get the resulting logistic regression equation, which looks a lot like simple linear regression. So these are the log odds of your outcome variable. This is the coefficient of the influence of your predictor variable. The problem is it's in log odds units, so we can't just take this and use it like we would with linear regression. Instead, we have to convert it from log odds to an odds ratio. And this is where this key on your calculator comes in, right? So if you've ever wondered what this is useful for, here's a use for it. Converting from log odds to an odds ratio. So the flow, you'll collect your data, do logistic regression, get your coefficient, take the exponentiation of it, and that gives you your odds ratio, the thing you're actually interested in. And what this is the odds of a positive outcome for your outcome variable if the predictor variable increases by 1 over the odds of a positive outcome if it stays the same. So this is giving you the odds ratio comparing, well, what are the odds if this variable increases over what are the odds if it stays the same. If it's less than 1, then increasing x, your predictor variable, decreases the odds of a positive outcome. If it's greater than 1, increasing x increases the odds of a positive outcome. And what you want is a large odds ratio, and you want statistical significance. So you want this odds ratio to be either very big away from 1, so 2 or 3 or 5 or 10, or very small, 0.1, 0.2. Either way, your predictor variable is having a large impact on the probability of a positive outcome for your outcome variable. Statistically significant, the p-value is giving you the probability that your beta is actually 0. So if your beta here is 0, e to the 0 is 1, and that means your odds ratio is 1, and your predictor variable doesn't really have an effect. So a large odds ratio with a statistically significant p-value means that we're confident that this is actually having an impact on the likelihood of a positive outcome.